An open source model, create this landing page. No Frontier Lab, no API key. It's Laguna S 2.1 and the weights are free. And it's not a toy. It beats DeepSeek Vive 4 Pro Max on Terminal Bench, a model 13 times its size. Those are Poolside's own numbers. Then you see the download, 236 gigabytes. So can you actually run it? Yes, 4 different ways. And one of them matches the hardware you already own. First, is this thing actually any good? On SweBench Multilingual, it scores 78.5. The top of Poolside's table, above DeepSeek at 1.6 trillion parameters, and Hunyuan 3 at 295 billion, both far bigger. Now the honest part, against the closed frontier, it doesn't win. On Terminal Bench, the top models on Poolside's own chart sit at 88. Laguna is 70.2. That gap is real, and it's the price of the download fitting on your machine. But look at what those models cost to run. Kimi K3 is 2.8 trillion parameters. Laguna is 118 billion with 8 active. It isn't the best model. It's the best model you can actually keep. So how does a model this big even fit? And the reason any of this works is one number. Laguna activates 8 billion parameters per token out of 118. The other 110 sit still. That's why a model this big doesn't need a data center. Now, the numbers that actually decide everything. So the sizes, because everything else depends on them. At full precision, that's the 236 gigabytes. At 8-bit, roughly 118. At 4-bit, around 65 to 70. Squeezed harder, near 40. Add 10 to 20 gigabytes on top of whichever one you pick. Cache files and context. Nobody mentions it, and everybody runs out of room because of it. Now the part you came for. One 24 gigabyte card, a 3090, a 4090, a 5090. Can it hold this model? No, not entirely in VRAM, not at any quantization worth running. So here are the 4 ways around it. Route 1, and it's the one that needs no offloading tricks at all. Apple Silicon, an M-series Max or Ultra, 96 or 128 gigabytes. MacOS hands that memory straight to the GPU. There's no separate VRAM to run out of. A 4-bit build lands around 68 gigabytes, leaving room for the system and a long context. Poolside ship official MLX conversions, so this path is supported day 1. Route 2, a big pile of system RAM and one ordinary GPU. 128 gigabytes of DDR4 or DDR5, plus a 16 or 24 gig card. Load it through Ollama, which Poolside supported on day 1, using their official GGUF build. The weights sit in system RAM, the active layers get handed to the GPU. Expect usable speeds rather than fast ones. And that only works because 8 billion parameters compute per step, not 118. Route 3. 2 or 3 consumer cards. 2 3090s or 2 4090s gets you 48 gigabytes of real VRAM. Split it across them with tensor parallelism in VLLM or SGLang. At a heavier quantization, around 42 gigabytes, the whole thing fits in VRAM with nothing spilling to system RAM. Fastest local option here, and the most expensive. Route 4, don't run it locally at all. Everything you've just watched ran on the free tier. That's Laguna S 2.1 free, through OpenCode, no hardware, and no download. OpenRouter also has a free endpoint at 256,000 tokens if you'd rather wire it up yourself. So, what does it actually build for you? I gave it an n-body gravity simulator. Real Newtonian physics, velocity Verlet integration, total energy drifting under 1%. It hit a syntax error partway through, spotted it, and fixed it. That's the part that matters. Not that it writes code, that it recovers. Then I asked for a landing page for a dev agency. One prompt, nav, hero, service cards, process section, contact form, all of it in one file. And Poolside's own team had it write an HTML and CSS rendering engine from scratch in 50 minutes. So, which one is yours? Mac with 128 gigs, Route 1, today. Gaming PC with a lot of RAM, Route 2, and be patient with it. 2 cards, Route 3. Everything else, or just curious, a Route 4, free. It isn't the best model. It's the best model you can actually keep. And that's a genuinely new thing to be able to say. If you get it running, tell me which route and what you got.